we're going to get started. I'd like to introduce Max, who is part of the founder of Sustainable Digital Infrastructure Alliance, SDIA, to introduce our panelists for our Zero Waste Data Centers panel discussion.
I love these chairs. I always look ridiculous sitting on them, and you get on. I always try to make entertaining panels, so it will be hopefully a bit funny. Please welcome to the stage, first of all, Madhu, Vice President of Products at Ampere, the chip guy today. Very nice. Then the storage guy, Alex from Data Cores. Welcome to stage. And last but not least, Carl, the crazy guy who makes wooden data centers. So we have an interesting panel name, right? Zero waste. So I think it's important from a moderation perspective that we quickly define waste, because otherwise it's going to be a very difficult discussion. So there's three things that can be wasted in IT and IT infrastructure. Energy, measured in kilowatt hours usually, resources, measured in adiabatic depletion potential. If you want to learn a cool term, that's a cool term. That's how many minerals you're taking out of the earth and you can never put them back, copper, steel, things like this. And the other one is electronic waste. So when Christoph is storing away his servers, it creates electronic waste. And those are the three forms of waste that can come out of IT infrastructure. With that being said, let's start talking a little bit with our wonderful panel. And I show you this picture of the value chain because I think it's important to realize that there's different actors in different parts of the IT infrastructure value chain. And today on this panel, I'm very happy because I have a representative from almost every part of this value chain, starting with Madhu. Quickly introduce yourself, maybe.
I'm Madhu Rangarajan. I'm VP of Products at Ampere. And I'll spend a good bit of time talking about our sustainability story and how I think we, as an industry, need to really get to that point where we are sustainable and generate very little or zero waste, as this panel is called.
Thank you. Alex, what about you? You represent the IT equipment part, but more on the storage side.
Yeah, and even there, we are more software, so we're a little bit more the glue in between all the components, because we do software-defined storage. Some say we even invented it. So we do that for more than 20 years now, and yeah, we have our own view on sustainability on that part, and we will look at that in a minute then.
Very happy to have you.
Thank you.
And Carl, maybe a short introduction from yourself.
Yeah, hi, I'm Carl. I'm from North Germany. I started out as a data center operator trying to use renewable energy, and I quickly realized the bigger issue is with the facility itself, and that's what I'm trying to fix now.
Thank you all. So I want to start with chips, but just a little bit logistics. If you have questions, we were going to do one round, and then afterwards we're going to start talking a little bit about the details. And you're very welcome to just stand up and ask a question or just join the discussion. Huh? It's not just us. If you want to go deeper, we can go deeper, as deep as you want. So let's start with chips. Huh? What's happening in chips? What about energy efficiency? What's the waste?
Sure. I think energy is, of course, the biggest part of the waste that you could consider in the chip industry. There's other stuff as well, but maybe I'll start with the energy part. If you look at the industry for a long time, right, there's always been this trade-off between performance and efficiency. And that kind of doesn't lead you to a good place in terms of minimizing waste, because people want the performance. When you go to a website on your phone, you want the instant response. People aren't willing to compromise. And because of that, that trade-off has always gone in favor of, well, we're going to generate more waste, but because we want the performance. If you look at an analog in the car industry, electric cars for a long time didn't really go anywhere because you always had this trade-off between performance and range and efficiency. When did it start going off? When Tesla started. And you actually didn't have to trade it off. You got the performance, and you got the range, and you got the efficiency. And that's really what we are trying to do in data centers, is we are creating chips that have the performance, have the efficiency, and have the density. And that's how I believe we can actually get to zero waste, is you have to address all of those. Once you give trade-offs, people always go for convenience, and they want the performance. And so that's how we're going to take care of the energy part of it. And then there's lots of other ways, right? And I know Carl's going to talk about it. Software plays a big role in making sure that hardware is utilized very effectively. And we play a role in making sure that the hardware we create can be used for a really long time, so we don't recycle and throw things away every couple of years and generate a lot of waste. So I think the chip industry has a very big role to play here to do the right thing.
I think so. It's the starting point for IT. So it always starts somewhere with a chip, and it's easy to forget about that, but it's a very important contribution. Alex, let's talk about storage, right?
Yeah.
It's a topic that not a lot of people appreciate how much footprint is sometimes attached to storage. It's always on, and this question that I always get, especially from politicians, what's the environmental footprint of 1 gigabyte of storage? That's a great question.
Nobody can tell you that, because it really depends how you store the data. So, for example, if you store data on tape, it doesn't cause any wattage, because a tape is sitting somewhere, and as long as it is not mounted in a tape drive, it doesn't eat up any energy. If you have online storage, it's totally different. You have a wide range of energy consumption there, because it also makes a difference if you read data versus if you write data. Writing data consumes much more energy than reading it. And then with the technology as it advanced, we're moving more and more towards solid state. In general, solid state uses less energy because you don't have those moving parts. You don't need to get the stuff spinning, but you waste energy in a different way to get data kind of in that stuff. But it goes down. It creates less heat. But where do your data actually go? The application tells, I need it fast, so it has to be on one thing. If the application tolerates a retrieval time of several seconds or maybe days, it could sit on tape and doesn't need any energy at all. But in the end, it is, again, as you said, the user, the end user, the application owner that makes that decision and that drives the demand for the one or the other form of storage. So net, I don't know.
I think that's in my work, trying to figure out what's the environmental footprint of digital products and services. That's the number one answer I get. Like, nobody actually knows how much energy is in there, how much resources are in there. And I'm a software developer, so I feel like we ought to know how much energy is in there. But I see your point, Carl. The data center. Why is it challenging? What's the problem you're trying to solve with the wooden approach?
So basically, there has always been this big discussion about the efficiency in the data center. We have, efficiency metrics that try to drive down the excess of energy you invest for cooling, for lighting, you create more efficient solution in the powertrain, in the UPS system, to really drive down that energy wasted. But there is a bigger issue here, because the 35% of all global emissions are tied to building and the building infrastructure, and so the bigger the elephant in the room is the Scope 3 emissions. And I was made aware of that, although I already was running sustainable data center on renewable energy for 5 years. I only found the toolbox with the tool being wood that has 5 times less embedded carbon than steel or steel concrete. And the interesting part about it is that it's very viable in terms of, you obviously get 2 questions with it. What's about fire and what's about humidity? And those questions are solved by the building engineers. You have all the tools to create a very safe data center from wood, up to terrorist threats with explosion safety, basically, and it will not be wood only. That's the important part. It's a compound of technologies, but it helps to not only run an efficient data center, which is the important part, but also create the lowest amount of embedded carbon. And with your favorite topic, in an ideal scenario, you would then also have the ability to use the heat of the equipment that is created by your products. My first initial step would be just raise the temperature. You know, don't invest in cooling. Just run it at 40 degrees. It's a machine room. It's not a human room. And that is something that is, I think, is the first step. You know, get the efficiency up. Don't invest energy in cooling.
Yeah, it's interesting you mentioned Scope 3. Just maybe a short interlude. If you look at Microsoft's latest, and I always say the names of the companies, I'm not trying to make a myth out of it. Microsoft's latest sustainability report, Scope 2 went down by about 5%. Scope 3 went up, I think, by 15%. Because as they grow, they have to buy more servers, and servers is in their Scope 3. And if you look at these things, then you also realize it's much more about the whole waste that is created and the supply chain, rather than just looking at electricity alone. Right? There's more components to it. Which brings us to I think the ultimate question in IT sustainability and in this waste discussion: who's responsible? Right?
So I think there's different types of responsibilities at different level, but at the end of the day, the person consuming all of this, the software developer, the application owner, is responsible for it, but they cannot do anything about it if they don't know what they're consuming, how much waste they're generating. So there needs to be transparency at every level of this, right? The chip needs to provide the right set of telemetry up to the operating system and various orchestration stacks to let them know this is how much energy is being consumed. Then they need to roll it up and take into account the Scope 3 emissions and everything else and roll it up to the end user. And then the end user needs to be aware of what they're consuming when they're running these services. And there's likely governmental responsibility as well to give the right set of incentives to drive the right behavior in order to get to true zero waste. So I think, yes, at the end of the day, the consumer, the application developer, they're responsible, but I think all of us have a shared responsibility in each part of the supply chain to make sure there's transparency and telemetry and data.
So if I compare it to a car, for example, the car is the ultimate product, but the entire supply chain of making the parts of the car have a responsibility to give the car manufacturer the information they need to actually determine the footprint, right?
Yes.
Can I do a little test? Is there any hosting company here or somebody who runs some kind of vServer rental or something like this? I know there's one there. Anybody else? Anybody from the hosting space? It's a hosting conference, anyway. So then I asked Christoph. Sorry, Christoph. Do you make the footprint of your infrastructure available to your customers? Is that something that, if I'm a software engineer, I build an application in on your hosting platform? Do I see the energy consumption of that piece of equipment I'm using?
Currently, you do not, because there's still a few missing pieces, especially in the virtualized and containerized infrastructures, to make it work. On the physical side, sure, every customer sees because he pays for it. Right?
But do you feel that that's your part of your responsibility to be transparent? Is that a necessity?
May not be today, but it will come one. At least that's what we do. So, looking forward to make it happen at some point.
Yeah, thanks.
Yep.
Appreciate it.
And I think he made a really important point, right? When you have a virtual machine, how do you know how much power you're using? And I think we all have to be part of that solution, and we have to work with the operators to make sure we are exposing the right set of telemetry. That's something that we are very interested in doing. We're building a cloud-native processor from the ground up, so we can actually do things like this and work with the hosters and work with all the end users to make sure we are exposing the right set of telemetry.
I think it's very important. It's a bit ironic because virtualization was all about forget about the physical infrastructure, and now you're trying to glue it all together. Alex, what's your view? Who's responsible?
I would like to phrase a question for the audience as well, if
Sure.
this is okay. Who owns a mobile phone taking pictures? Can you raise your hands? Okay. Who is having an Instagram account or something like that? Okay. And who is taking ridiculous pictures of each meal and send it around across the planet?
One brave one.
So the problem that we have with that growth, that enormous growth that we have, and it's moving exponential upwards, and we don't see it ending, is that we generate more and more useless data. Everybody says data is the new oil, and data needs to be stored. Now, the question is, what data do we really need? Do we need all those pictures of every meal that we have, and we have to send it to 100 people that again share it somewhere? Every of those pictures is stored somewhere. And because you have the demand to access those pictures quickly, what do you think where they live? Do you think they live on an energy-efficient tape? Or do you think they live on a very expensive flash architecture that is wasting energy every day in, day out? Think about that. And this is growing and growing and growing. And we differentiate on our side between what is called structured data, which is needed for the IT to operate and for a business to operate, and then unstructured, so-called secondary data that is just there in the case of. Yeah? We also have a lot of regulations today that force us to keep that data just in the case of. So let's say there's a car manufacturer, because you just brought that example. Now, if they manufacture a car in today's world, during the build-up process of that car, a lot of telemetry data is collected during the build process. And then this is all associated with the specific car chassis number. Now, if there is a problem alongside the manufacturer of the car can now, because of that data that he has, eventually call back a limited number of cars instead of all cars, right? The idea is to be more responsible, but on the other side, you generate a vast amount of data to just be ready in case of, yeah? And what I told you here is not just a made-up example. This is all the way true, everywhere in the industry. And guess what? It needs to be stored, and it needs to be available. And if we dial back a little bit in doing it differently, we won't waste all that energy, we won't waste all that material, and we won't create all that economical, toxical environment where we all live in. You know, we have only that one planet currently. I know they try to explore something else, but it has not worked out yet. And so far, I think we need to change that paradigm. We try to do that to some degree because we, for example, eliminate since 20 years the so-called stranded free space problem. And this is, again, a more consumer-developer problem. As a developer, when you, let's say, create a database, the first thing that you ask from your IT guy is storage, right? So let's say you want to plan for a 100 terabyte database. What would you demand?
100 terabytes.
Really?
Or 50 gigs or something, yeah?
No.
300 terabytes.
300 terabyte, because you want to be safe, because your database may grow and you don't want to go into that expensive process of acquiring additional storage, blah, blah, blah. You build your database, you think it's a wonderful product, you roll it out, and then nobody's using it. Yeah? And then in your 300 terabyte space, you actually store 10 gig, but the 300 terabytes are gone. With us, we actually provide a technology to detect what is really data, what is not, and you can dole out the 300 terabyte to make you happy. Yep. Yeah? But on the hardware side, we only allocate what is really needed because we know what is data and what not, to eliminate that waste in the first place. Yeah? Because nothing is more expensive than throwing that material into trash. Yeah? Not having it in the first place is one thing that we think makes a lot of sense, and we try to do that.
I think when I think about storage, you know, I think about all the hard drives that have already been manufactured, and I always feel like these photos, you know, that we don't access every day, the ones that are now a year old, that are somewhere far up in the stream, why don't we store them on, you know, older drives, older systems? But of course, I know it's not happening. And then I know there's Bob. Bob drives to the data center and shreds the drives because of data privacy reasons. And I always feel like, why don't we use those drives? Because we manufactured them, and to this picture, there's a lot of ADP in hard drives because it uses enormous amounts of raw minerals and really rare metals and yeah, stuff you don't want to know about where it comes from. And it feels like we should just extend the lifetime of this equipment. What do you think about that, Alex?
Absolutely. So in my lab I'm still running a server with our latest code and drives manufactured in 2008. They perfectly work, yeah? No problem. They are not the fastest on the planet, yeah? Possibly not the most energy efficient, but I think I still save much more energy by keeping them running than investing in new hardware, yeah? For now, at least for now.
Yeah, unfortunately, I wish I could give you now some statistics to back that up with some data, but as I mentioned in the beginning, it's very hard to get some data because nobody actually measures these things. Karl, back to the original question. Who, in your opinion, is responsible for reducing waste?
So in my belief, there is obviously, we have to make more conscious decisions, and we need the decision framework to do it, and it all boils down to management, you know, how we manage this, and are we really aware of the consequences of those decisions that we make, if it's, you know, the day-to-day of the Instagrammer with the food, and in most cases in IT today, in the cloud-native world, it's a buying decision, you know, and that is driven by a management decision to say we want to have, you know, the most sustainable option, or we want to make the most conscious decision. So we all three here only can make like an offer, you know, to the world, but eventually we have to have a market and a buyer that is conscious enough to say, yeah, we want the ARM architecture, and we want it in a wooden data center, for example, because of the consequences that we actually see and face, and that's why we make the decision. And that's my belief that it is coming down to the decisions we make in our day-to-day business.
Yeah, I like that answer. It's a lot about making the right decisions, but also then, which brings us to our next question. If I'm a manager and if I'm a software developer, I want data, right? I want to be able to measure it. I want to know how much energy is going into my AWS instance, how much embedded carbon is in there, how much resources was used to manufacture it. Do you feel, Martin, that we have this data today, this transparency, and ways to measure that?
I think on the compute side, there are lots of measurements that are available, right? There's performance per watt. Of course, there's complexity there because performance as measured by what? Is it Nginx performance? Is it Redis performance? Is it like a synthetic benchmark like spec int rate? So there's many measures of performance, but I think there is broad acceptance of a set of performance metrics, and you can say, what is my performance per watt? And that at least gives you an idea of your operational carbon. But then you go back to the point that he raised, which is, how do I take that performance per watt and divide it up among the different virtual machines and the different tenants? And yeah, we do have some knobs for that, but I think we have to increasingly get better at that at a system level, because it's not just about the CPU. There's memory, there's storage in the system. So overall, what's your virtual machine consuming in terms of the operating energy across all of those components? And then comes the embodied carbon. I think you were talking about the stuff, the space it takes in the data center, right? Density is an important aspect of that. How many cores do you have in a certain form factor and certain energy footprint? And how many data centers do you need to fit 10 billion cores? And all of that also has to then be decomposed down to every individual user. So I think it's actually possible to get there. It's just going to take people at multiple levels working with each other to get it there. So I think on the compute side, we have the metrics. I think it's a matter of getting it done.
Yeah, I agree. I have to inject some advertising. I'm really sorry, but I'm a non-profit. I'm allowed to advertise sometimes. We actually solved this problem. So we did build a tool in Kubernetes. It's hopefully going to run in Christoph's data center that can do this attribution, because that's really the holy grail, and there's a lot of research around the world to figure that out. How do you attribute memory use, CPU use to a specific machine? It's not rock solid yet, but it's 80% there. And I highly recommend, if you're interested in that, to just check it out. It's on GitHub, it's open source, it's not commercial. It's called the digital carbon footprint. And I think, though, it would be a lot more helpful if vendors like Ampere can give more APIs on the actual chips, but that's a different discussion. Alex, storage. So you said measuring the energy consumption and the resource use per gigabyte is hard,
Yeah.
but are we getting closer to that? Are there other measures that I can look at?
Yeah, you know, storage is usually attributed with three factors. It is called, for sure, it's also the capacity itself, but then you have also what is called I/O rates, throughput, and latency. Yeah, and this is actually defined by the application demand. So if you have something that is lazy, then you can have a high latency, low throughput, low I/O rate, and this comes alongside with low energy consumption. And on the other end of the spectrum, everything is low latency, high I/O rate, high throughput. This is a high energy situation. There's, in the storage world, the Storage Performance Council that runs an official benchmark initiative, and we were doing benchmarks in that. And it was going crazy in 2015, 16, something around, because everybody tried to break a record of another million IOPS something, yeah? We finally broke the benchmark because we created so many IOs that they stopped measuring. So the needle was just bumping at the meter, if you like, yeah? So they then had to reconstruct the benchmark. But the interesting part of that is not that we broke that record. The interesting part is that the second best, yeah, compared to us, was just insane. So we put a system there that was 4 rack units in total for running that benchmark, and we broke it. The system before us was filling 10 racks full of hardware. So just think about all the material that went into that, plus the energy it is consuming for doing less. And then something they introduced was something like the I/O per dollar price performance. We even abstracted the latency per dollar out of that, which is an interesting indicator, because you have to disclose the hardware and the retail price for that hardware that you run that benchmark with. And now imagine 10 racks full of hardware versus 4 units of hardware. I think the math is really simple, yeah, to get that. So.
Yeah, there's also always some truth in just looking at the financials. If you're buying hardware worth 10 million euros, there must be an equivalent of aluminium, cobalt, copper that went somehow into that system. Now, Karl, data centers we both love. There's a lot of metrics in the data center world. None of them ever reveal actual numbers, PUE, WUE, CUE, you pick it. Do you feel like there is a framework that's actually useful in measuring waste and sustainability in a data center?
So I think a starting point is the holistic measurement of the greenhouse emissions in all 3 scopes over the life cycle of equipment. You know, that's very hard to do, especially for scope 3. We're just starting to be on this journey and work with some companies and organizations to try and compare. You know, and that's also one reason to open source all of my designs, to be able to have people extract or check, you know, how much volume, how much weight is actually in those how much wood or steel comparably is in those designs, and this is the most difficult and to do so. So a lot of people really try to stay, you know, and with renewable energy and scope 1 and 2. That's relatively easy because, as Christoph said, you see it on your bill, right? What you consume, but it gets really tricky, and trying to work with you together to make that you know, visible.
Yeah, I think so as well. I think it's difficult still to make it really measurable. Maybe just to try, right? If anybody has a question and wants to interject on this measuring topic, or you have an idea or you have a comment, now is a good time if you want. No, otherwise you get continued conversation. Then I'll throw you an unprepared question. If you could make one wish towards, so to say, the value chain above you, so the developer, the data center owner, or whoever is, so to say, your customer's customer, what would you wish from them in terms of sustainability? What should they change in their business?
I think what I would want them to change is today, we talk to infrastructure people who really understand the value of the efficiency and how they can pack so many more cores in the same data center footprint without building an extra data center and things like that. The developer and the application owners are completely disconnected from that. And they're in the space of, no, I don't care. I don't want to take a risk. I want to just keep running what I'm running. And it's your problem. You deal with it. I think the two need to get connected. And the developers also need to be accountable directly, more directly, for how much energy and how much waste that is created by their applications. I think today, structurally, that connection doesn't exist. So I would like that connection to be made.
That's wonderful. I would love that connection to be made, especially in cloud and virtualized environments, yeah, for sure. Alex, what about you? What's your wish? To who?
My wish. Yeah, I would like to learn why we need data and why we can get rid of data. German law, for example, has that part of data avoidance, I think, in German data protection law, yeah? But somehow nobody avoids it. So on the other side, you know, I shoot myself in the foot here because we make our living on selling licenses for capacity, but on the other side, I think it would be better for all of us if we would be more cautious on what do we really need to store digitally. Do we need all that? Do we need all that convenience? I don't know. I can live with it, but I'm an old guy, yeah? So from that perspective, if I look at my daughter, she can't live without a digital device, and she lives kind of in Instagram. I don't understand that whole buzz around it. If I have to take a photo, I can also take it on paper. Anyhow, different story. Yeah, so more responsibility for all of us, because we create that environment, we create the demand. If we don't create the demand, the application developers will not develop into that area. Yeah, so it's all of us.
Yeah, when you talk about data waste, I think about log files. That's my. I remember. Yeah, it's a different story. But log files, like sometimes developers don't have rotate the logs. They just live there for 100 years, and you never. It's not that you actually need to look at the logs that you had from 2 years ago, right? You always want to know what's going on right now. That's one area that would be very easy.
You know, there's a great invention we have that's called the delete button. So we should possibly use it more often.
But it's cheaper to hoard digital stuff than to hoard physical stuff. Right?
Yeah, it's easier to not think. Yeah, because deleting means you need to think and you need to be sure that you really don't need it. But yeah, you may need it eventually.
Especially in Germany, you always never know when you still need that file.
Yeah.
Karl, what about you? If you can make one wish, to who?
I believe, you know, in an ideal scenario, we each individual and organizations, we know on which trajectory we would actually be in terms of, you know, if the ultimate goal is to stay within 1.5 or 2 degrees. So is our, you know, sustained approach on living and organizing or managing our resources, are we actually moving in the right direction, or are we on a solid 4 degrees, you know, race? So, and I think that would, you know, just help a lot of people, you know, even if they say, okay, yeah, I'm fine with, or I need the comfort. I know I'm destroying, you know, our planet in a way, but they just have to be aware where they're heading. You know, that I think would my wish be for them to have the information where they're heading.
Yeah, I sometimes wish more people would at least look at the IPCC report a little bit. There's a few people running around here about planting trees, and you can scan the sweater and they plant a tree. But the IPCC report literally said we all get offsetting. Offsetting is working really well, but people are forgetting that we actually need to adopt our business practices. We need to use refurbished equipment, right, instead of new equipment. We really need to redesign most businesses today, transport, and you will all say IT doesn't matter, but IT will be the last thing standing. Once everything is decarbonized, transport, food, agriculture, then IT will be the biggest chunk of all emissions, right? Because everything will be digitalized and that will grow while everything else is shrinking. And we really need to take responsibility for the footprint that we create. And we still have a little bit of time, but I just, on the measuring piece, again, sorry for some advertising, but I need to educate people a bit. There's all these metrics that IT people know, and I'm an IT person, so I also understand them, but I just want you to realize, it's maybe hard to read, but the world has already agreed on the metrics. They're very simple. They're called the life cycle assessment. Every object in this room will have a life cycle assessment and a product passport in the next 5 to 10 years. This chair, Christoph's band here, the t-shirt, the shirt that I'm wearing, everything will have a life cycle assessment. And that's also what we need to effectively decarbonize the world. So CO2 equivalents in kilograms, that's interesting. Primary energy use in megajoules or kilowatt hours, that's interesting. And those metrics we need to measure, and we need to make them transparent to software, so that software can be accountable for the footprint it creates in infrastructure. And it's really important, because I know most of you are not building applications, probably, but we need to make that data available to them. The supply chain needs to be transparent in order for us to manufacture a sustainable car. And I think the development community, when I go to KubeCon or DroidCon or all these developer conferences, they give standing ovations when they learn that they can actually, that they are in charge of making software sustainable, and that they have an active role to play, and they want to play that role, but we need to give them the information, especially here in this conference. We are the cloud providers. We need to give them the information they need to reduce their footprint. And that's how we get to zero waste IT, hopefully. With this, I would propose that we close and go get some lunch, because it's 3 minutes in. The clock is not correct, if you're wondering. And we close it here. If there's no questions, if you have a question, shout now. No shouts. Then we close the panel. Thank you very much. Thanks for joining.